Hey everybody, it's Mrs. C, and what I wanted to do is just a quick little overview of using the quadratic formula, and then the next time I'll probably be doing an intuition on graphing the quadratic formula. So real quick, a lot of you already know how to use the quadratic formula, but I thought, wouldn't it be nice to have a little pen cast just to remind us? So here we go. You want to start with what the quadratic formula is, so let's start with it. You can say it along with me if you know it. It's x is equal to negative b plus minus the square root of b squared minus 4ac over the whole thing over 2a. And what this does is it gives you a bunch of variables. You've got a's, b's, and c's, and each of those variables is assigned a particular part of a quadratic trinomial. You plug in those values, you do what it tells you to do, and you actually will get the solutions to the quadratic. Solutions being where the function intersects the x-axis. So let's take a look at a sweet little baby function. Y is equal to x squared plus 5x plus 6. Oh, so sweet. You know, this would be so easy to solve by factoring, and just I want to show you kind of the opposite of solving by the quadratic formula would be solved by factoring, and by opposite I mean easy versus difficult. So solving by factoring, you just set your y equal to 0, as you want to find out where this function hits the x. So that would mean your y value is 0, and we just break it down into factoring. X, let's see, we want a sum of 5 and a product of 6. That's going to be a 2 and a 3, right? Plus, plus. So we find that the factored form of x squared plus 5x plus 6 is x plus 2 times x plus 3. Set equal to 0 and solve x plus 2 is equal to 0. Well, that means x is equal to a negative 2. And x plus 3 equals 0. I'll just do it over here. Then you can see you'd minus 3. Sorry if I'm shortcutting, but not really doing a lesson on solving by factoring. You see this answer is x equals to negative 3. So let me just move that out of the way. For more details, please see a prior pencast on solving by factoring. So here's what I know. The solutions are going to be negative 3 and negative 2. So if all goes well, I'll get that answer when I'm done. So you're probably thinking to yourself, if you don't know how to do this, that's awesome. Oh, why would I do it any other way? Well, you wouldn't, not on a problem like this. However, I like to start with a simple problem to give you a little more clarity. So how do you start? You write down, for example, A, B, and C, and you look at the original trinomial. I'm going to get a little, oops, sorry about that. You have no idea what I'm doing, but I'm trying to get some more stuff out of my way. You start with the original trinomial. It was x squared plus 5x plus 6. All right, so the a's, the b's, and the c's represent your different terms of your trinomial. This is a trinomial, and it has 3 different terms. That's why it's a trinomial. Now, the coefficients of these terms will identify, what your A, your B, and your C is. So the A belongs to the coefficient of your quadratic, and in this case, you see it's a 1. The B refers to the coefficient of your linear, and that's a 5. The C refers to the constant itself, and that's a 6. So here we have it. Our A is 1, our B is 5, and our C is 6. And yes, it's really that easy. So what you want to do is plug in those values into the quadratic formula. Everywhere you see an A, you put a 1. So let's do it. Everywhere you see a B, you put a 5. Everywhere you see a C, you put a 6. Now, of course, the relationship between these is not, I don't have minus 416. We have to remember that that was a multiplication relationship, and yes, I do see that I erased my 5. I thank you for helping me out there. It wasn't a 5. It was a 1. Got it. I didn't erase it. Oh my goodness. All right. So let's do a little evaluating. Up here, I'm going to start right here so you can see where my mind is. I have a negative 5. Okay. That was easy. I guess I should copy the x equals. I always yell at my students when they don't. Plus minus square root of 5 squared. Why don't we just do that? 25. Minus 4 times 1 times 6, not minus 416. So I'll just do, minus 4 times 6 is 24 times 1 is 24. So that was nice. That whole quantity is over 2 times 1. 2. Now we continue to simplify until, we're as simplified as we can possibly be. So I'm going to use the beauty and wonders of being able to erase what I'm doing. And I'm going to just ask you, what is 25 minus 24? Yes, that is right. It's 1. Now, of course, you would just continue writing your process, but I don't want to use another page, so I'm just going to put the 1 there. And look, I just can't do too much more here, so let me make a little room and ask you, the viewer, how would you simplify negative 5 plus minus the square root of 1 over 2? We'll just keep simplifying. Can you do anything to a negative 5? No. Can you tell me what the square root of 1 is? I hope so. Square root of 1 is 1. So we would actually have a negative 5 plus minus 1 over 2. Now I'm going to go to the next page. We had x is equal to a negative 5 plus minus 1 over 2. And what this means is there's 2 different ways x can go. You can say a negative 5 plus 1, or you could even say a negative 5 minus 1. And those 2 different situations, once you divide them by 2, are going to give you 2 different values. So look at what we have. We have x could be equal to a negative 5 plus 1 over 2, but it can also be equal to x equals negative 5 minus 1 over 2, and you see how that's going to give you different answers, right? Negative 5 plus 1 is what? It's a negative 4. And negative 5 minus 1 is negative 6. When you do a negative 4 divided by 2, the result is going to be a negative 2. And when you do a negative 6 divided by 2, the result is going to be a negative 3. I don't know if you remember, but the answers we got when we did the quick factor method were x equals negative 2. I'll do a little bracket. Where's my negative? Down there. Negative 2, negative 3. I like to put those usually in order least to greatest, but I'll survive for now. So get the same answer, right? Which one's easier? Clearly, I hope you would say the factoring method is easier, but the quadratic formula wasn't really invented to help you when you could have done a method that was easier like factoring. The quadratic formula is there for you when you can't factor. When you can't find a sum and a product that go together, you've got the quadratic formula to help you out. So I hope this helps you. It was a short video. I said it was going to be just a quick little overview of using the quadratic formula. I hope this helped you out. I will have another video pretty soon on intuition of graphing quadratics. Ooh, they're so much fun. They're pretty and they're complicated and they're interesting and they're, oh gosh, I don't know how I'm going to stop from just jumping right in and doing it now, but I'm going to show restraint. For now, just wanted to give you a little insight on using the quadratic formula. You know what? You're awesome. I love you. And I'll see you on the flip side.